Rotational and circular motion, chapter number 5, solve numerical problems. Problem number 1. A string 1 meter long is used to whirl a 100-gram stone in a horizontal circle at a speed of 2 meters per second. Find the tension in the string. For example, this is a stone and this is a string. The length of the string is given as 1 meter and the mass of this stone is given as 100 gram, where 100 gram is equal to 0.1 kilogram. And the speed of this stone, the linear speed of the stone, is given as v is equal to 2 meter per second. Find the tension T in the string. Solution. Okay, let's calculate the tension T in the string. The force acting on the string are: one is the tension force, which is balancing the centripetal force. And now in this situation, the centripetal force is in this direction, where the tension T is in this direction. In such a situation, we can write that T minus Fc is equal to 0, where Fc is the centripetal force. And now T is equal to Fc. Tension T in this string is equal to the centripetal force. Now let's calculate the centripetal force acting on this string. According to the definition of centripetal force, we know that Fc is equal to mv square divided by r. Putting this value for Fc in this equation, we will get tension T is equal to m into v square divided by r. Now here we know the value of mass, which is 0.1 kilogram. The velocity is given as 2 meter per second, and radius r is given as length of the string, which is equal to 1 meter. Putting the values for m, v and r in this equation, we will get T is equal to 0.1 2 square divided by 1. Solving this, we will get 2 multiplied 2 square is equal to 4. 4 multiplied by 0.1 is equal to 0.4. Divided by 1, we will get 0.4 Newton. And the tension T in the string is equal to 0.4 Newton. This is the required answer. Now let's solve problem number 2. Problem number 2 is: the moon revolves around the earth in almost a circle of radius 3,82,400 km in 27.3 days. It means in 27.3 days, the moon complete one revolution. It means that the moon complete one revolution around the earth in 27.3 days. So what is the centripetal acceleration? Now we are going to calculate the centripetal acceleration given data. In given data, it is given that the radius of the orbit is equal to 3,82,400 km. We will convert this kilometer into simple meters because we will use SI units for solving numerical problems. Converting this to standard meter, we will multiply this term with 1000 and we will get this term meter, which is something like 3.824 multiplied by 10 power 8. Okay, the time taken to complete one revolution is given as 27.3 days. We will convert this 27.3 days into seconds. Multiplying this 27.3 by 24, we will get hours. There are 24 hours in one day and 60 minutes in 1 hour and 60 seconds in 1 minute. Multiplying this with 24, 60 and then again 60, we will get this term, and this is the equal of 27.3 days in seconds. Now the centripetal acceleration AC is equal to unknown. We will calculate the centripetal acceleration. Let's solve this problem. The centripetal acceleration AC is given as AC is equal to v square divided by r, where the v square or the v is the linear velocity and the linear velocity is equal to r omega, where r is the radius and omega is the angular velocity. So we will get AC is equal to R omega whole square divided by R. Further simplifying this equation, we will get R square omega square divided by R. This one R will cancel out with this R square and we will be left with R omega square. And the centrifugal acceleration is equal to R omega square. Here for the calculation of centrifugal acceleration, we will need R radius of the moon, which is given as 3,82,400 kilometer, and in meter this is the term used for, this is the radius of the moon, where the omega square is angular velocity. We will calculate the angular velocity in radian per second. Angular velocity will be the time during which it complete one revolution, and we know that the angular velocity is equal to omega is equal to del theta divided by t. Now here the del theta is equal to one revolution, one complete rotation of the moon around the earth, and we know that one revolution of any circle is equal to 2 pi radian divided by del t. The time during which it will complete one circle is given as 27.3 days. Putting the value for del theta and del t, we get 2 multiplied by 3.14 divided by 2358720, which in turn is equal to 2.67 multiplied 10 power minus 6 radian per seconds. And this is the value for angular velocity omega. Now putting the value of omega and radius r in this equation number 1, we will get AC angular acceleration is equal to R omega square is equal to 3.824 multiplied 10 power 8 into 2.67 multiplied 10 power minus 6 whole square. Simplifying this equation, you can do this by calculator, and solving this we will get centrifugal acceleration AC is equal to 27.26 multiplied 10 power minus 4. Shifting this point minus 4 dot to here, we will get 0.002726 meter per second square, and this is the required centrifugal acceleration. Problem number 3. Statement of problem number 3 is a ball of mass m tied to one end of a string is whirled from the other end in a vertical circle of radius r with constant speed. Here this is the string, this is the ball tied to this string, and it is whirled vertically like this. Find out the tension T in the string when the ball is at the highest point. It means if the part 1 of this problem is calculate the tension T in the string when the ball is here, and the point 2 is calculate the tension T in the string when the ball is at the lowest point in the path of motion. The part 2 is we will calculate the tension when the ball is here. Now at highest point when the ball is here, the tension T is equal to Fc, and this tension T is in the upward direction, where minus Fg is the weight of the ball. Centrifugal force minus weight of the ball. So the weight of the ball is due to the gravity, and the gravity is acting downward, where the tension T is acting upward. That's why we write it as T is equal to Fc minus Fg, where Fc is the centrifugal force, which is equal to mv square divided by r, and minus into mg, mass of the ball and gravity. Taking m common from this equation, we will get tension T is equal to m into v square divided by r minus g. And this is the tension T in the string when the ball is at the highest point at this point. Now let's solve this equation for the tension T when the ball is at the lowest point. When the ball is at the lowest point, the tension T again here is in the downward direction, and the gravity is also in the downward direction. So both have the same directions. We will add up these two forces. Then tension T is equal to Fc centripetal force plus Fg, the gravitational force. Putting the values for centripetal force plus the gravitational force, we will get tension T is equal to mv square divided by r plus mg. Taking m common from this equation, we will get tension T is equal to m into v square by r plus g, where g is the gravity and this is the tension T when the ball is at the lowest point in its path of motion. Problem number 4. A motor car is traveling at a speed of 30 meters per second. If its wheel has a diameter of 1.5 meter, find its angular speed in radian per second and in revolution per second. Given data. The speed of the car is given as 30 meters per second. This is the linear speed of the car and is represented by v is equal to 30 meters per second. The diameter of the wheel is given as 1.5 meter. This is the diameter. This diameter of the car is equal to 1.5 meter. Converting this diameter to radius, we will get radius of the wheel is equal to 1.5 divided by 2 is equal to 0.75. So the radius, this radius of the wheel is 0.75 meter. The question is, find its angular speed omega. We will calculate angular speed omega in revolution per second and in radian per seconds. Let's solve this problem. We know that the angular speed and the linear velocity is related to each other by this equation. V is equal to r omega, where v is the velocity, linear velocity, r is the radius, and omega is the angular velocity. Solving this equation for angular velocity, we will get omega is equal to v by r, where linear velocity is given as 30 meters per second and we know the radius is 0.75 meter. Putting the values for linear velocity v and radius r, we will get 30 meters per second divided by 0.75 meter. So the angular velocity is equal to 40 radian per second. This is the part first of the problem. We have calculated angular velocity, which is equal to 40 radian per second in radians. Now we will convert this 40 radian per second into revolution per second. Now let's convert this 40 radian per second into revolution per second. We know that 1 revolution is equal to 2 pi radian, where 1 radian will become equal to 1 over 2 pi revolution. Now here, putting the value for radian in this equation, we will get omega is equal to 40 into 1 over 2 pi revolution divided by seconds. We will get 40 divided by 2 pi. 3.14 is the value of pi. Solving this, we will get 6.36 revolution per seconds. Hence the angular speed omega is equal to 40 radian per second, which is equal to 6.36 revolution per second. Problem number 5. An electric motor is running at 1800 revolution per minute. It comes to rest in 20 seconds. If the angular acceleration is uniform, find the number of revolution it made before stopping. So we will be going to calculate the theta, or number of revolution before stopping. Given data is angular speed omega is equal to 1800 revolution per minute. Converting this 1800 revolution per minute into revolution per second, omega is equal to 1800 revolution divided by 60 seconds, as 1 minute is equal to 60 seconds. Dividing this 1800 by this 60, we will get 30 revolution per seconds. So this is the angular velocity in SI unit. Now time taken before coming to rest is given as 20 seconds. Number of revolution before stopping theta is equal to unknown. We will solve this equation by using two equations. Number one is the second equation of motion, which is S is equal to VIT plus 1 over 2 AT square. But here we are dealing with the angular motion, so we will write this equation in terms of theta, where theta is the distance traveled or the revolution equal to omega naught. Omega is the angular velocity, initial angular velocity, and t is the time taken plus 1 over 2 into alpha t square, where this alpha is the angular acceleration. Now in this given data, alpha is unknown, so we will first determine the value of alpha. For calculating the value of alpha, we will use first equation of motion, which is Vf final velocity is equal to Vi plus At. But here again we are dealing with angular motion, so in terms of angular velocity we can write that equation as omega 1 is equal to omega naught plus alpha t. We will calculate the value of alpha from this equation. So when the motor car stop, it means that the final angular velocity of the motor car will be equal to 0. So we are going to put the value of omega 1 equal to 0, where omega naught is given as 30 revolution per second plus alpha, and t is given as 20 seconds. Shifting this term to the other side of the equation, we will get 20 as alpha is equal to minus 30 revolution per second. Dividing both sides by 30, we will get minus 1.5 revolution per second square, and this is the value of angular acceleration. Now putting the values for omega naught, t, alpha angular acceleration, and again t in this equation, and solving for theta, we will get theta is equal to 30 into 20 plus 1 over 2 into minus 1.5, which is alpha into 20 square t square. We will get 30 multiplied by 20 as 600 minus 600 divided by 2 equal to 600 minus 300, which is equal to 300 revolution. This theta represents the number of revolution before the electric motor stop. Okay, this was the part 1. For other 5 problems of this chapter, stay in touch and watch our second video. Thank you for watching, and don't forget to subscribe, comment your questions. Thank you.